Hi, this video will discuss the development process of my project, which is the gas monitoring and alert transponder system. The first thing I'll mention is that I went through two of these gas sensors during development. Turns out I had slightly miswired this voltage regulator here, so it went on battery power. It was slowly eroding the sensor. I was giving it a little over 5 volts. This is meant to take 3.3. So it was getting a little too much voltage and it was slowly killing the sensor, giving me flaky communication and also giving me some funny values. So finally figured out the problem, wired up the voltage regulator properly, and I've got one good sensor out of the 3 that I have. But I can still demonstrate the system without having this sensor actually being able to take any readings. So it's not an issue. All right, well, continuing on, to give a more full demo of the system, which is fairly feature-rich, and there wasn't nearly enough time in the 2-minute video that I did. So let's go through it. First thing, we can test the system.
Alarm test.
Notice up here, it says alarm remote. And you also notice probably we get a vibration from the vibration motor, and we also get an audio signal or notification. The purpose of this is redundant on purpose because the system's meant to be worn by a worker, and I want to have multiple ways to inform them that they've gotten into a dangerous environment or that they're beyond their limit for the day for exposure. So that's why I've got not only an audio signal or notification, but also a vibration indicator as well. So that, that way the system pretty much goes off and has a high chance of alerting the person since it is a safety device. Okay, another thing you can do with the system is these threshold values are settable. You can change them, you can raise them and lower them. This is for the TVOC and for the CO2 levels, the TVOC being the most important. And when the system is armed, then these threshold values, if they're breached by the values collected, it'll set off the system. You'll get that kind of response where you'll get an audio, a notification, a vibration, and it will transmit to the other transponders in the area saying, hey, there's an alarm is being triggered. Further down the development process, in future development, obviously I'd want to have a unique ID for each transponder. So that way when the transponder receives an alarm code, it knows which transponder is sending it, which is not that important between 2 transponders, but since I can support up to 20 with this arrangement, it would be very important to have IDs so we know who's triggering their alarm. Let's see, another feature is everything is stored in EEPROM, so even down to the threshold values that you set. So let's just,
Warning threshold violated.
Well, here's a good example
Warning threshold violated.
of what happens when you
Warning threshold
violate a threshold. And so to stop this,
threshold violated.
we'll just reset the system. But you can see right there what happens when the alarm is set and you exceed the threshold value. System triggers, sends a code to the other transponder. You kind of get the idea there. Okay, so back to what we were saying. If we can, change threshold values, it'll store them in EEPROM. So let's leave the alarm off this time, and let's lower it. Okay, 400, whatever, and then we'll turn it off. And then we can turn it back on, and of course, it's still going to have 400 as the value, and that's true for pretty much every value that I use. It's very important for the total weighted average and for the minutes because if you end up replacing your battery, you don't want to lose all your data. So pretty much all data, all settings are stored in the EEPROM. Okay, another thing. Let's see. I believe we already showed the alarm test and the reset button. And the last two things. Probably should go into more detail. So the total weighted average. That's probably the most important metric out of all of them because this is what the worker is going to rely upon throughout the work day and the work week. This is the most important one because this is the accumulated exposure, really. That's what the total weighted average is. It's how much exposure they've had that day or that week. As long as it's under 500 parts per billion, the system will not trigger. If this value exceeds 500, then the system will trigger and alert other transponding units. Now, if you want to monitor another transponder, you can easily do that by pressing these two buttons. This will go into the remote data window. And from this, it'll pull the TWA from this guy. It's at 0 because we just did a hard reset. Here, what I'll do is we'll do a hard reset, and then I'll blow on the sensor with this window open. Okay, so watch TWA. It's slowly going to go up. Slowly going to go up, and that's because these values are, yeah, you know, getting there, but they're still fairly low. The room I'm in does not have a high amount of TVOCs. But as you can see, the value up here is also changing. It's at 5 TWA. Okay, so as you can see, it is live data. And so all these windows are live as well. Everything is at, real time. You can also see up here, it says the VOCs are 1, VOCs are 1. VOCs 5, VOCs 5 is a very slight delay, but it's pretty close. So anyways, that's my project. As far as future development, definitely want to work on unique IDs. I thought if I could either have that be a settable feature by the person who powers on the device, or maybe that's not good. I could also just use the last 4 or 5 digits of the Zigbee serial number as the identifier that's used by the system. That's maybe a little more reliable. It depends on the environment that I'm going to be putting these in. So anyways, that's my project. That's a more comprehensive demo. I hope you enjoyed it. Thanks. Bye-bye.